All right, so right now we are starting in Chapter 4, Section 1, and we are going to talk about analyzing functions. And the important thing that we're talking about today is determining whether or not a function is increasing, decreasing, or, hold on, these kids are screaming in the hall. Okay, so today we're going to talk about whether the functions are increasing or decreasing, and then we're going to talk about concavity. So the first thing we want to review real fast is increasing. Remember, we read graphs from left to right. So if your pen on the left side goes up when you trace the curve, then what that means is your function is increasing. If your pencil's moving down, you are decreasing. Remember, we read graphs from left to right. So when we do these key features, this point here, this point, these are important pieces of the graph. We want to know what's happening so that we can get a better idea as to what the function is telling us. Okay? So there's a couple of definitions. And the first definition that we need to know is that if your first derivative, oh, we're not there yet. So taking a look at our graph, some function value here and some function value here. If your function value is increasing, remember, function values are y values. So this is y1 and this is y2. Okay? So if y1 is less than y2, it means you're going up. If y2 is less than y1, you're going down. If there's no change, it's constant. Okay? So now what we're talking about is slope. So if I draw in my tangent lines, you can see what's happening to the slope of those tangent lines. The tangent line here has a positive slope, but it is decreasing. Here you have tangent lines whose slope is increasing in the negative direction, so we say it's decreasing. And here we have a constant slope, okay? So positive slopes mean your function is increasing. Negative slope means your function is decreasing. We're going to call this the first derivative test. So the first derivative test pretty much says if your function is positive, your tangent line slopes. So I'm pretending these are my tangent line slopes, line segments, if you will. Notice that the slopes of these lines are all negative. Negative slope means your function is decreasing. Positive slopes means your function is increasing. Okay? In order to go from one to the other, you have to go through a very special value, 0. Okay? So I can look at that picture and I can say that that's a parabola, and I know that it's decreasing from about negative infinity to 2, and then from 2 to infinity it is increasing. But I'm going to use the derivative test, and I'm going to follow these 3 rules. And so the way that works is you take the derivative of your given function, in this case, our derivative. You're going to set it equal to 0. You're going to solve for x. And then you're going to do what we call the first derivative test, or a sign chart, or the sign test. And I'm going to put this number right here. Now, Mr. Clinton may have a different method by which he shows his work. I'm going to use this in my class because it's very visual for me. So in my head, this is the number that I need to look to the right and to the left of. So I'm going to choose the easiest number that I can think of to the left of 2. This is my thinking bubble. I'm thinking, and I'm going to choose the best number I can here. And then what I'm going to do with this number is I'm going to plug it into my derivative. Remember, if this is the first derivative test, I should be plugging 0 into my first derivative. Well, 2 times 0 is 0, and 0 minus 4 is a negative. I don't care what the value is. I only care what the sign is, which is why this is called a sign chart. Now I'm going to take this one and I'm going to plug it in. So 2 times 3 is 6, and 6 minus 4 is 2, which is positive, so that's a positive value. And now I can say that my function is decreasing, that f is decreasing from negative infinity to 2, and f is increasing from 2 to infinity. Example 2. Find the intervals over which x cubed is increasing and where it is decreasing. Well, I should be thinking this in my head. I know the curve. From left to right, that thing's going up all the time. But we're going to confirm that. So we're going to take the derivative. We're going to set the derivative equal to 0. We're going to solve for x. And now we're going to make a sign chart. So I'm going to choose 2 numbers to the right and left. And now I'm going to plug them in. That says that my function is increasing from negative infinity to infinity. And I'm talking about x values, right? I'm talking about x values. Example 3. Use the graph to make a conjecture about the intervals. Well, I'm going to make a conjecture. And I'm drawing in where I think it's changing. This is just a guess. It's a guess. So I'm guessing it's decreasing until about 2. And then from 2 to 0, it's increasing. And then from 0 to 1, it's decreasing. And then from 1 to infinity, it's increasing. So I'm just looking at the picture and I'm saying, okay, look, it's going down to here, and then it's going up, and then it's going down, and then it's going up. So I'm breaking it up into 4 parts. And now I'm going to prove that using my calculus. So I take the derivative, 12x cubed minus 12x squared minus 24x. And I'm going to factor out a 12x, and I'm going to get x squared minus x minus 2. And I want to factor. And now I'm going to use some algebra and do zero product property. So x is either 0, 2, or negative 1. And I'm going to come over here and, wow, Miss Collins, you're so smart. I know. And 2. And those are my points that I need to look to the right and left of. So I'm going to choose a number over here. I'm going to choose a number here. I'm going to choose a number here, and I'm going to choose a number here. And so now I'm going to plug in negative 2. Remember, this is my first derivative test. So I'm going to come right here, and this right here is my first derivative test. So 12x, x minus 2, x plus 1. And I'm going to plug in several values here. I'm going to plug in negative 2. That would make this negative, negative, negative. A negative times a negative times a negative is negative. If I plug in 1/2, I'm going to get a positive number, a negative number, and a positive number. Notice, I do not care what the value is. I'm doing it on a small scale. So 1/2 minus 2 is going to give me a negative number. Plus 1 is going to give me positive, and this is negative, by the way. Miss Collins, you silly girl. And so that makes this different. I forgot my minus sign. See? Please show your work. This is a minus right there. So this is a minus, this is a minus, and this is a plus. And a minus times a minus, plus times a plus is plus. Now I'm going to plug in 1. I'm going to plug in 1. I get a plus, I get a minus, and I get a plus. And when I plug in 3, I get a plus, and a plus, which is a plus, plus, plus. Now let's come back up and take a look. It appears that my function is decreasing from negative infinity to negative 1. I am increasing from negative 1 to 0. I am decreasing from 0 to 2. And I am increasing from 2 to infinity. Notice the picture above, right here, would indicate that I'm correct. Look at my green arrows compared to my blue arrows. So comparing the arrows, look at that. Well done. So the picture that we learned to graph in Algebra 2, that we graphed again in pre-calc, we are now analyzing that using calculus in calculus. If you can graph it, you can do this. The first derivative test should just be reinforcement. Okay, the second thing we're going to talk about is concavity. And concavity means it's either going to be catching water or spilling water. That's how I look at it. So if rain were falling, I'm either going to catch it or my umbrella is going to let it spill over. Okay? And the way we look at this is we take a look at the second derivative test. If the second derivative is greater than 0, meaning positive, if the second derivative is positive, you are concave up. If the second derivative is negative, you are concave down. Okay? So concave up, positive, concave down, negative. So now when we come over here and we take a look at these, notice we want to take a look at the second derivative. So the first derivative of the first graph would be 2x minus 4. This is the same as example 1. The second derivative is 2. Well, 2 is positive always. And look, it's up, concave up. Now let's come over here. First derivative, this is example 2 and 3, I believe. We got 3x squared. Second derivative, we get 6x. We're going to do this. 6x equals 0, so x equals 0. At this point, we're going to do what we call the second derivative test, which works exactly the same as the first derivative, except we're using the second. So I'm choosing a sign to the left and the right, and now I'm going to plug it in. So 6 times negative 1 is a negative number. 6 times a positive number is a positive number. So this would imply that I'm concave down from negative infinity to 0, and I am concave up from 0 to infinity. Now here's the deal. Look at concave down. That's going to be umbrella. Concave up, bull, catching. Okay? All right. Now the point at which you change concavity is called an inflection point. And that is really the point that we're looking at where your second derivative is equal to 0. Okay? We call that an inflection point if the concavity changes the direction of concavity. Okay? If it changes the direction of concavity. So in our last example, I'm going to slide back. In our last example, 0 changed signs. It went from a negative on one side to a positive on the other. That's a change in concavity. So I would say that an inflection point is 0, 0. Okay, that's my inflection point at x equals 0. Okay, so let's see. So there's a graph, and we want to find out all inflection points. So we want to find out lots of things. We want f is increasing, decreasing, concave up, concave down, and inflection points. Okay? So the first thing I want to do is take the first derivative. And I take the first derivative, I get that. I want to take the first derivative, and I want to set it equal to 0. I want to make my sign chart. I want to choose a number to the left and right of each of those. And now I want to test them in the first derivative. So I want to put in negative 1, and I get negative values. When I plug in positive, I still get negative values. Oh, this column, you silly girl. Negative times a negative is positive. A positive times a negative is negative. And a positive times a positive is positive. Okay, so here's what I did. 3 times -1 times -1 minus 2. This is a negative, and this is a negative. 2 negatives make a positive. Okay, so now I can say I'm increasing from -infinity to 0 and 2 to infinity. This is my union sign. Or I could say and. Okay, f is decreasing from 0 to 2. Now, to do the second part, I'm going to go ahead and take the derivative of the derivative. So f prime of x was equal to 3x squared minus 6x. I want to do the second derivative, 6x minus 6. I now take that and I set it equal to 0. I solve. I sign chart. Plug in 0 to my derivative. I get a negative number. Plug in 2. I get a positive number. That says that I am concave down from -infinity to 1, and I am concave up from 1 to infinity. It also tells me that I have an inflection point at x equals 1. And the way I find out where that inflection point is I take this 1 and I plug it into the original function. So my original function is here. So 1 minus 3 plus 1. 2 minus 3 is -1. So 1, -1. Oh, look, it's right here. Good job. So I have an inflection point at 1, -1. Okay? So those are going to be the 5 steps you have to do. Find the first derivative. Set it equal to 0, sign chart. Find the second derivative. Set it equal to 0, sign chart. Last thing, determine if you have an inflection point. Okay? Example 6. This one's a little harder. So if you would like to, pause now and try this on your own. First derivative, derivative of the first times the second, plus the derivative of the second times the first. So I'm going to factor out an e to the -x, set it equal to 0. This will never be 0. The number that makes this 0 is x equals 1. Sign chart. Number to the left, number to the right. Plug it in. If I plug in 0, I get a positive number. If I plug in 2, I get a negative number. Therefore, I am increasing from -infinity to 1, and I am decreasing from 1 to infinity. The next thing I need to do, second derivative. So I'm going to take the derivative of the first. The derivative of the first is negative e to the -x minus the derivative of the first times the second plus the derivative of the second times the first. So negative e to the -x minus e to the -x plus x e to the -x. So you get 2 factor set equal to 0. That should be a plus sign. Too messy. This is never going to be 0. So the only number that's going to make this 0 is 2. So now I'm going to sign chart. Number to the left, number to the right. So when I plug in 1, I'm going to get a negative number. When I plug in 3, I'm going to get a positive number. And that says that I am concave down on -infinity to 2. I am concave up from 2 to infinity. And because I am changing concavity at 2, I have an inflection point at x equals 2. Now I come back up to the original equation, and I evaluate that at x equals 2, in which case I'm going to get 2 over e squared. So my inflection point is at 2, comma, 2 over e squared. Okay? 1, 2, 3, 4 pieces. 5, 6 pieces. 5 bits of information for every function. Okay, last example, I believe. Turning my notes just to make sure. Nope, I have 2 more examples. Okay, so the first thing we're going to do, take the derivative. Take the derivative, set it equal to 0. Solve for my variable. So where is the cosine equal to negative 1/2? That's at x equals 2 pi over 3 and 4 pi over 3. So sine chart, 2 pi over 3, 4 pi over 3, a point to the left. Let's go 0. A point in the middle, and a point on the end. What's up, Serge? And now I'm going to do my first derivative test. So I take my, I want to take my 0, and I want to plug it back here into my derivative. And the cosine of 0 is 1, so this is going to be positive. Plug in pi. The cosine of pi is negative, so this is going to be negative. And the cosine of 2 pi is positive. This will be positive. So f is increasing from negative infinity to 2 pi over 3, and from 4 pi over 3 to infinity here. And because I think I'm given bounds, I need to change my infinities. So that needs to be 0, and this needs to be 2 pi. Okay, the next thing I need to do is the second derivative. So I'm going to go ahead and take my first derivative, and I'm going to take the derivative, and I'm going to get negative 2 sine x, and I want to set that equal to 0. And that's going to happen where x is 0, pi, and 2 pi. So I'm going to sine chart it, 0, pi, and 2 pi. So I'm going to choose a halfway point, because those are the ones I remember from the unit circle. And the sine of pi over 2 is 1. So 2 times 1, negative. And the sine of 3 pi over 2 is negative 1, negative 2, positive. And so now I can say that I am concave down from 0 to pi, and I am concave up from pi to 2 pi. And therefore, I have an inflection point at pi. Going back to my original equation, pi, and I plug it into my original equation, I end up with pi plus 0, which is pi. So 1, 2, 3, 4, 1, 2, 3, and 5 on 2 pi over 3 to 4 pi over 3. Now, if you do what I just did and you just accidentally skip a step, you can figure it out if you have all your work on your paper. Okay, the next example, it just says find the inflection points. So what I want to do is make sure I read the question, because at this point, all I want to do is go to the second derivative, set it equal to 0, sine chart it, plug in a number to the left and to the right, and realize that when I do this, there are no inflection points. My concavity did not change. Okay? All right. You are now going to do the quick check. It's important that you understand that I'm less concerned with the formal notation like this, but what we should be understanding is that A and B become our endpoints, X is in between, little details. The answers are on page 244. This is on page 240 in your book. Please come to class on Monday with these notes done. Thank you. Have a great weekend.